Okay, so at this point we are finishing our lesson on section 6.3, vectors in the plane. You already started this lesson last class, or I should say as your blended learning day assignment. Just stick it on the desk. And so you are already familiar with the idea of this directed line segments. So these are just the notes that, that you saw on the video for the blended learning assignment. You know what component form is, got those kind of component braces, and you know how to find that by taking the difference. You take the terminal point minus the initial, right? Terminal minus initial to get the component form. You know how to find the magnitude, which is the length of the vector, by using the distance formula. And you did some examples of finding the component form. Then you went to scalar multiplication and vector addition. And so you're familiar with, if you have a scalar like -2, you can multiply that through to get your new vector. And for this example, the original vector v was 3, 4, which meant it goes from 0, 0 to the ordered pair 3, 4. And if we want -2 times that vector v, that would be -6, -8, which means it's going in the opposite direction, and it's twice as long. All right. And let's see, then we talked about adding vectors geometrically. So positioning them. So if I'm adding vector u and v, I can take this vector and put it at the tail, put the head of the vector with the tail of the first vector, and I end up connecting with a diagonal. It's called the parallelogram law, the diagonal of a parallelogram. Okay, so let's see, we did those, skipping along here. All right, so then we did unit vector. Vector with a magnitude of 1. And to find a unit vector, which I'm sure I'm going to ask you on a quiz, find a unit vector. Did you do that on the blended learning also? You did? Okay. So to find a unit vector, you find the magnitude first, and then you multiply through the vector by 1 over that magnitude. All right. So find a unit vector u. This is the example we did. Find the unit vector u in the direction of 7, -3, and verify that the result has a magnitude of 1. So you find the magnitude first. So that's going to be square root of 7 squared plus a -3 squared. And that turns out to be square root of 58. So that's the magnitude of this vector right here. And then the unit vector would be 1 over square root of 58 multiplied through the 7, -3 vector. So we get 7 over square root of 58, comma, -3 over square root of 58. And then if you want to show that that vector really does have a length of 1 or a magnitude of 1, you can find the magnitude of that unit vector by taking square root of 7 over square root of 58 squared plus -3 over square root of 58 squared. And we end up getting 7 squared is 49, square root of 58 squared is just 58. -3 squared is +9, square root of 58 squared is 58. I add these, I get 58 over 58, which is 1, and the square root of 1 is 1. So that's how we show that. Okay, and moving on to the unit vectors. So we say I is a unit vector if it's boldface I, and it's just the little vector 1, 0. So starting at 0, 0 and going to 1, 0, that's just this little vector right here would be considered I. Then J is the standard unit vector that goes in a vertical direction, so that's 0, 1. So that's just this little guy right here. All right. So, and I did put this note, but I know we haven't done chapter 2 yet, or finished chapter 2. But in chapter 2, you will learn about the imaginary unit I, so just don't get those confused. Yes, we'll get there in chapter 2. Okay, so boldface I, boldface J, those are our standard unit vectors, and they can be used to represent any vector. So V1, 1, 0, V2, 0, 1. So if I want to add those, I can get any linear combination. So here's an example that we did on the video. Let vector u be the vector with initial point -2, 6, terminal point -8, 3. Write boldface u as a linear combination of the standard unit vectors. And so we do terminal minus initial, so -8 minus a -2 is going to be -6, and 3 minus 6 is going to be a -3. But then the -6 is telling you that you want to go 6 units in the negative direction horizontally, and then this -3 says go down 3 units vertically. So this would be your standard unit vector. All right, except I slid this. Was this supposed to look like this, perhaps? All right, probably so.
Can you write the distance or the magnitude formula on it for it? Is it just y2?
It's just a distance point. So you're taking the difference in the x coordinates from the terminal minus terminal plus initial.
So that's y2 minus
Yeah, yeah, difference, right?
Does it matter if you put y2 minus y1 or x2 minus x1?
It doesn't matter because you're adding those together and taking the square root. That's right. Okay, so let's skip along to this. Did we talk about direction angles on the video? No, I don't. I think this is where I stopped. All right, so let's pick it up from right here. So if vector u is a unit vector such that theta is the angle measured counterclockwise from the positive x-axis to vector u, the terminal point of vector u lies on the unit circle, and vector u is going to be x comma y, and that's also going to be cosine of theta comma sine of theta, or we could write it as cosine of theta times unit vector I plus sine of theta times unit vector j. So let's talk about what that means. A picture speaks 1,000 words. So picture that you have a unit circle, all right, and you have some, here's 0, 0 on our unit circle, and we have some vector, all right, that vector v here, like this. Okay, vector v, let's say, goes to point AB. That's somewhere that's not on the unit circle. But if we were able to find the unit vector that has that same direction, it would look like this, right? It'd be this unit vector u right here, where the terminal point lies right on the unit circle. All right, so because of that, this point right here on the unit circle, let's call it xy, is the same as saying, oh, and by the way, the angle here is theta. That goes from the positive x-axis angled up to our vector v or our vector u. So that's our angle. And so since this point right here is xy, we could also write this. We know from our work with trigonometry that that's going to be the cosine of theta comma sine of theta, right? The x-coordinate is the cosine, the y-coordinate is the sine. Okay, so that means that this little vector right here could be written in vector braces as the vector that goes from 0, 0 to cosine theta, sine theta in vector braces. So I can write it like this. All right. So the angle theta is said to be the direction angle of vector u. All right. The angle theta is the direction angle of the vector. So if v is a, go back up. So if v is a vector that makes an angle theta with the positive x-axis, then it has the same direction as vector u, and you can write it as I said earlier, the vector v, the magnitude, cosine theta, sine theta. So if you take that magnitude of vector v times cosine of theta, I can write it times the not the imaginary, see, now I'm going to say it, the unit vector I plus magnitude of v times sine of theta j, and this is all a long-winded explanation for why we can write, I've got it written really big, because this is the important part, that the tangent of theta is always going to be equal to b over a. So if you want to see where this comes from, you can kind of follow along with this. And so there's some vector v that ends at some point AB. Exactly. So let's take a look at a sample problem. So let's say we have this example, and you're supposed to find the direction angle of this vector. Let's say this vector is the vector -6, 6. So we know it's going from 0, 0 to -6, 6. Is that point on the unit circle? No. There's some unit circle that'd be really little right here, but we're not on that unit circle. That point's way past that. All right, but if we want to find the direction angle, what we need to do is we can say that the tangent of theta is equal to b over a. So that would be 6 over negative 6. So that's equal to negative 1. Was I just holding something that I said? I'm missing one of these. Oh well. All right, we'll find it. So theta, yes I am.
Hello. Hi, Hertz.
Okay, so tangent of theta is equal to b, oh, thank you. Where was it? Thank you. All right, so, okay, so tangent of theta is going to be negative 1. So to find theta, you're going to have to find tangent inverse of negative 1. And on your calculator, go ahead and grab your calculator, please. What does it tell you if you do tangent of theta equals negative 1? On your calculator, do tangent inverse of negative 1. What's it equal to?
Negative 0.75 radians.
All right, can you convert that to degrees, please?
Oh, yeah, sure.
Negative 45. So your calculator is telling you negative 45 degrees. But take a look at the picture. Does this angle here in blue look like it's negative 45? No. So you've got to add 180 to that to get our actual direction angle. So what would that be? 135. So that's why our direction angle for this picture is 135. So you can't blindly trust your calculator. You've got to use a little thinking, a little reasoning. Are we okay with this? Because oh, this is me just reminding you that tangent inverse. So why is it giving you negative 45 instead of 135? Because your calculator is programmed to tell you tangent inverse, and you remember from section 4.7. Gentlemen, am I going to have to ask one of you to leave that table? You heard me. Can you stop? You're distracting me. So stop. So you know the tangent inverse is going to be some angle between negative pi over 2 and pi over 2, or between negative 90 and 90, right? So in this case, it's going to tell you negative 45, but you see the picture, and the picture clearly shows it going into the second quadrant, not the fourth quadrant. So that's why you have to make that adjustment, add 180. Are we okay with this? All right. Okay, so let's see.
Are you going to post this note to the website?
Sure. Okay, so let's take a look at this problem. Find the direction angle. Vector v is negative 7, unit vector I, minus 4 times standard unit vector j. So I need you to tell me what is the a and what is the b in this problem. Is this one on your gift?
Yes.
It is? Okay, Paul.
Your A is -7.
A is negative 7, negative 4. Because this right now is written as a combination of standard unit vectors, but it could have been written in component form as negative 7, comma, negative 4. Everybody agree? So here's our picture of what the vector looks like. And it ends up here at the ordered pair, negative 7, negative 4. So if we're looking for the direction angle, that means we're trying to find this angle. Oh, I got that all locked. But this angle right here. All right? So what is the tangent of theta going to equal? Angelo?
It would be negative, so it's 4/7.
4/7, because we want Okay, B over A, -4 over -7, so we get 4/7. So how are we going to find theta? Theta is going to be equal to arctangent of 4/7. Grab your calculator. Would you figure this out and give me a degree answer, please?
Be the vector.
Pardon me?
Just be the vector.
V is the vector. Right. Hold this one. All right, so theta equals 29 points. What is it? 29.74 degrees. Is that our answer? We've got to add what? 180, because we do want to end up in quadrant 3, as we can see from the picture. So that ends up being what? All right. Are we okay? Are we okay with this?
Don't do it.
All right, let's try this example. Find the component form of the vector that represents the velocity of an airplane descending at a speed of 100 miles per hour at an angle 45 degrees below the horizontal. It's angling down. It's angling down. All right. Shh. In order to do this problem, you're going to want to take the magnitude of vector v times cosine theta times the standard unit vector I plus the magnitude of vector v times the sine of theta times standard unit vector j. So in this case, our magnitude is going to be the speed of the plane. So it's 100 miles per hour, so that's our magnitude of our vector. So that's 100. We fill that in here and here. This angle, since it's 45 degrees below the horizontal, angling this way in our picture, that's going to be 225 degrees. Everybody comfortable with that? All right, and so we're going to say 100 times cosine of 225 times the standard unit vector I plus 100 times the sine of 225. What are those trig values? Square root of 2 over 2? Negative. All right. And so that means, and I've got my standard unit vectors here also, that means that I could write it in component form then as, wouldn't it be, what, I can, 100 over 2 gives me -50 square root of 2, comma, -50 square root of 2, correct? Are we okay with this? That's the yeah, well, that's if you're going to write it as a combination of the standard unit vectors, but the directions were to write it in component form, and so this is component form.
So you just
Drop the I and the J and put them in the vector braces with a comma instead of a plus or a minus.
Is the first part of the v equals magnitude, is that given?
Right, that's a formula for this type of problem, yes. You take the magnitude times the cosine. And the reason we have to use this formula is because the cosine theta comma sine of theta would only get us the angle on a little unit circle, right? So we've got to multiply by the 100 to get us to the distance we want to go from that point.
We didn't even need the 45 degrees below.
We did because we had to use that to get the 225 degree angle,
But then it already.
right?
Oh, it was already written.
I already wrote it in, but that was just us getting started on the problem. All right, let's see. From the picture. We had to kind of go by the picture. Okay, let's take a look at this example. Is this one also on your gift? Okay, so at this point, it says an airplane is traveling at a speed of 724 kilometers per hour at a bearing of north 30 degrees east. If the wind velocity is 32 kilometers per hour from the west, find the resultant speed and direction of the plane. So to find the resultant speed and direction, you really have to add the two vectors together that are at work here. So vector V1 is going to be the vector represented by the plane itself. Vector V2 is going to be the wind acting on that plane. And so we're going to have to add those two vectors together. So V1, we're going to need to take, remember, it's take the speed of the plane, that's going to be our magnitude, and multiply it by cosine of, and I ruined this already, north 30 degrees east. Here's north 30 degrees east. You with me?
Yeah.
That's a 30-degree angle right here. So does that make sense why we would say this angle from here to here is 60, right? Okay, so that's why we have 724 times in component form cosine 60 comma sine 60. All right? Yes, degrees. And so that's going to be 724 times what is the cosine of 60? 1/2, and the sine? Radical 3 over 2. So we have that here, and then when we distribute that, can we get, let's get a decimal approximation for this. Well, 724 times 1/2 is 362, comma, and then 724 times square root of 3 divided by 2 is going to be,
627.0039.
give me one decimal place, 627.0. Are we okay with this? Does everyone agree? Everybody should be checking this themselves. Is this okay? So at this point, are we okay with this? At this point, let's talk about vector V2, the wind vector. I've got it drawn up here, but let's actually picture if we had put it down here, right? It's going from 0, 0 to what? 32, comma, 0, right? Because that's the magnitude of that vector. And so how would I write that vector in component form? Is it 32, 0? Wait, never, scratch that. Scratch that. Let's start again. If we want V2, let's do it the same way we did this. We had 32 as the magnitude, right? And then what is it's going to be cosine of what, comma, sine of what?
60.
What angle is it heading? It's heading straight along the positive part of the x-axis. 0. So it's really cosine of 0 degrees, sine of 0 degrees. Agreed? So that's going to be,
Yeah, I don't know.
you know, are we okay with that? Because it's not angled up at all. My angle's not moving. The initial side of my angle and the terminal side of the angle are still both right on the positive part of the x-axis. So it's still 0 degree angle, so, right? So it's going to be 32 times cosine of 0 degrees, sine of 0 degrees. And so when we work that out, what is the cosine of 0? Cosine of 0 is 1, and the sine of 0 is 0. So I've got 32 times 1 comma 0, the vector in component form, 1 comma 0.
What's the x value?
So I just get this equaling 32 comma 0.
Then you add those together.
And then we add those together. So to get the answer for this problem, remember V is equal to, I got it right here.
394.
So I'm going to add 362 comma 627 plus 32 comma 0, right? And so what are we getting?
394, 627.
Does that make sense?
Yeah.
Okay, so what did we just find?
We found the direction of the plane.
Actually, I think we found the component form of the resultant vector, but we did not answer either part yet. We still need to find the resultant speed and the direction. We did 90% of the work,
Yeah.
but we still didn't answer the question yet, so we still need to finish this up.
For
Allison.
Why is the x value 0 if it's moving?
Why is this a 0 here and here?
Yeah.
Because the wind is going straight from the west, which means it's heading straight east, which means it's sitting right on the positive part of the x-axis, which means it's not rotating it. We don't have any kind of rotation. It's just 0 degrees. You know, on a unit circle, if I have an angle that just looks like this, don't I call that 0 degrees?
Yeah.
Right. Pardon me?
No, then the things would switch.
If the wind was blowing out of the south, going straight to the north, then we'd be talking about a 90-degree angle.
So
Does that make
like
sense?
If it was coming from the south, it would be 032, right?
Correct, because it'd be a 90-degree angle. Yes. Okay, so we are ready to answer what is the resultant speed. How do we find that? Because I think with this wind blowing, it might not just be going 724 kilometers per hour. The wind is pushing on the plane. It might be making it faster, might be making it slower. How are we going to find the resultant speed? The resultant speed is the same as the what? Starts with an M. Magnitude. So how do we find the magnitude of, where's my vector?
Oh, you do distance.
Sure. So we just want,
So
so we want the magnitude of vector v. This is going to be the resultant speed, right? It's going to be equal to square root of 394 squared plus 627 squared. Calculators.
Hold up. 394.
739.5, and that's pretty close to the 724, but it's, you know, the wind is helping it go a little bit faster, but it is pushing it off course a little bit, right? So we've got to figure out what the direction of the plane is. But are we all okay with this?
Yeah.
All right, so this is the resultant speed is 739.5, and
that's km per hour.
that's, yes, kilometers per hour. Thank you for keeping units in our lives, kilometers per hour. Okay, and then what about the direction? How are we going to find the direction of the plane?
You take the arctangent of 627 over 394.
Oh boy.
Yeah.
All right, so the direction is going to be, we're going to say tangent of theta is equal to what over what?
627 over 394.
Everybody agree with this statement right here?
That's
B over A. B over A, yep. Oh, wow. We did. What's wrong with the magnitude?
It's actually 740.5.
What do we think? You guys are telling me I don't have a calculator in my hand.
Yeah,
Is it 740?
as I mean, that was one off. Okay, well, it's still going to change our.
Are we agreeing now? 740.5?
No, that's not a Patrick purposely got
All right, shh. Okay, so theta is going to be tangent inverse. of 627 divided by 394. Did you get this figured out?
I got it to equal 57.8 degrees.
What is it?
57.8 degrees.
57.8.
That's not the direction of the plane, though. Isn't the direction of the plane like, I have it north 32.2 degrees east.
How'd you get that?
I subtracted 57.8 from 90.
All right, so you're saying if this angle right here is 57.8 degrees, then if I want to write the direction angle of the plane that's been pushed off course a little bit, you're going to have to subtract that from 90, and you're going to write your answer as north, what was it?
32.2 degrees east.
Oh, just try to write it like bearing.
As a bearing, yes. Are we okay with this? Everybody all right with this problem? Yeah. Questions on this one?
So direction is always tangent B over A.
Tangent of theta is always b over a, and that's how you find your direction angle.
So for number 1 on the skip, two different.
Number 1 on the gift.
For part B, when it says show they are the same direction.
Oh, that one, you only had to find the slopes of those two segments to show they have the same direction. All right. Questions on anything we've talked about from the gift or from the notes? Okay, so that kind of completes our notes, and I think what I would like to do is stop this video, and then we'll talk about some of the homework problems that I've assigned you. All right.